Hello everyone, welcome to my channel. So I've started offering specialized one-on-one classes in physics, chemistry and math EE for both SL and HL. So for the rates, the standard rate is $35 per hour. If you book like 5 or more classes, it'll be 30, and if you book 10 or more, it'll be 25. So these courses will be tailored to your needs. Whatever you want to learn, we can discuss in these classes. Please don't hesitate to reach out to me. You can contact me at this given email and yeah, to schedule your class. So with this, let's get started with this paper. Thank you. Hello everyone, welcome back to my channel. So today we'll be solving Chemistry SL Paper 1A of Timezone A. So let's get started with the first question. So we are projecting a beam of particles across a positive and negative electrodes. The particle Y will pass straight through without getting attracted to any electrodes. That's why Y will be a neutron. Yeah, so you can reject A and B. This is a neutron. Yeah. X is attracted towards the positive electrode. So X should have a negative charge. Electrons have negative charge, so X should be an electron. Z is attracted towards a negative electrode, right? So Z should have a positive charge. So Z is a proton. The proton is Z, electron is X, neutron is Y, which is option C. Now we have to find out which of the following species have the same number of outer electrons. Okay. Um, can actually find which ones will have the same number of electrons and then can just make a conclusion that if two species have the same number of electrons, they'll also have the same number of outer electrons. For W, right? It has 12, it should have 12 electrons. It has a +2 charge, so that has two less electrons from 12. So that is 10. X. X should have 16 electrons in a neutral, when it's neutral, but it has a negative charge. That means it has one extra electron. Y should have 21 electrons, but it has two electrons less. It will be 19. Z, 9. It has a negative charge. That means it has one more electron than the protons. So it's 10. We see W and Z, they have the same number of electrons. And hence, I can make the conclusion that they will also have the same number of outer electrons. Answer is D. And question 3. Uh, which diagram shows the correct electronic configuration of nitrogen? Electronic configuration of nitrogen. So nitrogen has total of 7 electrons, right? The electronic configuration is 1s2, 2s2, 2p3. Okay. Now, 1s2, 2s2 will be completely filled. So it will be like this. This is 1s, this is 2s. Yeah. And for 2p, I will singly fill the orbitals first and then I'll start pairing. So I filled 3 electrons in 3p orbitals. So that's it. So answer will be option A. Now, next. Which shows a gas that would deviate least from ideal gas behavior? Okay. So first, we have to check which gas has lower intermolecular force of attraction, right? In NH3, you have hydrogen bonding because hydrogen is directly attached to nitrogen. Okay. But in pH3, you just have dipole-dipole interaction. So force of intermolecular force of attraction is weaker for phosphine, right? And hence I can first eliminate option B and option D. Either it will be option A or it will be option C. Now, at high pressure, what happens is the molecules are close to each other, right? And if the molecules are closer to each other, there will be some amount of intermolecular force of attraction. Yeah. And if there are intermolecular forces of attraction, then the gas will deviate from the ideal gas behavior because in ideal gas behavior, we assume that there are no intermolecular forces of attraction. So pressure high cannot be correct. So pressure has to be low and the gas has to be phosphine. Just from this information, we can say option A would be the right answer. Okay. And high temperature also makes sense because at high temperature, you have a lot of kinetic energy, but the potential energy will be low. So the molecules will be moving faster. Next. Which row shows the shape of S and P orbitals? S is a spherical orbital, P is a dumbbell-shaped orbital. So answer would be D. Spherical, then a dumbbell shape. Volume of container filled with fixed amount of gas is increased by 100% at constant temperature. So if your initial volume was V1, your final volume will be is increased by 100%, right? So it should be twice V1. Yeah, when you double something, then you increase it by 100%. So you can do P1 V1 by T1 equals P2 V2 by T2. This is the equation of state. We can use this directly. It's at constant temperature, so T1 should be equal to T2. We can cancel this one out. Yeah. So P1 V1 equals twice P2 V1. Now you can cancel V. So P2 would be P1 by 2. So your final pressure is 50% of the initial pressure. So I can say pressure decreases by 50%, which is option D. The next one, which row shows the correct formula and electronic configuration for the species in calcium nitride? Calcium nitride, the ions are Ca2 plus and N3 minus. Calcium ion is Ca2 plus, nitride ion is N3 minus. Yeah. So if I combine them together, it will be Ca3N2. Yeah. The formula will be Ca3N2. I can remove A and B from here. Yeah. Now, both calcium and nitrogen will be in their noble gas states, right? So calcium will lose two electrons. Calcium generally has electronic configuration of Ar4s2, but if you remove two electrons, it becomes Ar. Similarly, nitrogen has, only nitrogen has 2s2, 2p3, but N3 minus, there will be three more electrons. So the electronic configuration of nitrogen will be neon, Ne. Answer would be option D. Next. Diagrams of four stable allotropes of carbon are shown. We have to identify which rows correctly identifies each structure. Yeah. So the ball is, of course, fullerene. Fullerene looks like a football. Yeah. X, we can see three bonds with each carbon, and it's a layered structure. So this is graphite. For Z, you see each carbon makes three bonds, but it's only one sheet. So this is graphene. And the last one, W, it's a 3D structure, and each carbon makes four bonds. So this is diamond. Diamond will be W, graphite will be X, fullerene will be Y, graphene will be Z. Answer is option A. Yeah. Next, in which of the following molecules do all atoms obey the octet rule? Okay, in NF3, if I draw this, the Lewis structure looks like this. So you see each and every atom has a complete octet. So NS3 definitely follows the octet rule. For BF3, the structure looks like this. Yeah. So you see in BF3, each fluorine has 8 electrons around in its outer shell, but boron has 6 electrons. So BF3 does not follow the octet rule. And for PCl3 again, PCl3 will have very similar structure to NF3. So again in PCl3, all the atoms have a complete octet. So answer would be 1 and 3 only, which is option B. Next one, which compound has a weakest ionic bond? So the ions here are Mg2 plus, Ca2 plus, O2 minus, S2 minus. So the ions have the same charges, Mg2 plus, Ca2 plus, same positive charge, S2 minus, O2 minus, same positive charge. So we cannot differentiate based on the charge. Next, we have to differentiate based on the ionic size. Because if you have bigger ions, what happens is the distance between two ions will be greater. If the distance increases, the force of attraction will decrease. Yeah. So between Mg and Ca, this one is bigger. Okay. And between oxygen and sulfur, sulfur will be bigger. So CaS should have the weakest ionic bond, which is option D. Next, which row puts these molecules in order of decreasing bond angle? So NH3 has a pyramidal structure. It has three bond pairs and one lone pair. Yeah. Uh, H2O has two bond pairs, two lone pairs, so it's a bent structure. CH4 will have a perfect tetrahedral structure. Okay. And C2H4 will have a trigonal planar structure. No lone pairs. So for C2H4, around carbon, there are three bond pairs. It's trigonal planar, so this bond angle will be 120 degrees. For tetrahedral, the bond angle is 109 degrees approximately. Now there's a trick which I share in class, that is, if you have a structure and if you're adding an electron, I mean lone pair, for each lone pair you can decrease the bond angle by 2 degrees. Yeah. So for NH3 the bond angle will be 107 degrees. For H2O the bond angle will be 105 degrees. So decreasing bond angle, so highest should be at the first, lowest should be at the end. So C2H4, CH3, NH3, H2O. Option C is the right answer. Now next. The following TL's thin layer chromatogram was obtained from a mixture of naphthalene, which is C10H8, and naphthol, which is C10H8O. Polar silica was used as a stationary phase and a nonpolar hexane as mobile phase. Okay. Now naphthalene, right? Naphthalene is nonpolar, obviously. Yeah. So, and silica is the stationary phase is silica, right? And naphthol is polar. So naphthol will be attracted to this polar silica, but naphthalene won't be attracted by the polar silica because naphthalene is non-polar. So naphthalene will travel further, okay? And this will travel a smaller distance because of the attraction to stationary phase, right? Now, if I check the chromatogram, X is on top, so X should be our naphthalene. Okay. So NaHCO3 is the limiting reactant. Yeah. So now we have the limiting reactant. From here, we'll find the moles of water produced, like by stoichiometric ratio. Moles of NaHCO3. This ratio would be 3:3. Okay. So moles of H2O will basically be equal to moles of sodium carbonate 0.05. Okay. Now, next, you have to find the heat produced, which is MC delta T. Yeah. Mm. So mass of the mixture. Okay, 50 centimeter cube. Right? So we'll take this. We'll just take water. Okay. 50 centimeter cube of water will have a weight of 50 grams. Okay. So 50 times C is 4.18. And delta T. Delta T would be final temperature minus initial temperature. Okay. So if I solve this, I'll get minus 209 joules. That is the heat produced. And finally, delta H is negative Q over moles of water. Okay. Negative of negative 209 divided by 0.05. So this becomes 4180 joules per mole. Now we'll make divided with 1000 to convert it to kilojoules. 4.18 kilojoules per mole. Answer would be option A. Now moving on to question 20, chloroethane. It's produced by the reaction of ethane with chlorine. We define the atom economy. So percentage atom economy. Atom economy is molar mass of desired product divided by molar mass of all reactants. So here chloroethane is our desired product, right? Molar mass of chloroethane, C2H5Cl is 64.52, given in the question, right? And total molar mass of the reactants, C2H6 is 30.08, Cl2 is 70.9. If you plug this in your calculator, you'll approximately get 63.9%, which is option C. Next, we have combustion of propane with oxygen. 75 centimeter cube of propane was completely burnt in 400 centimeter cube of oxygen. So I know all of the propane has burnt. So propane is the limiting reactant, oxygen is the excess reactant. Okay. Now I can use the volume ratio. Volume of O2 reacted divided by volume of propane reacted, CH3, CH2, CH3. This would be 5:1, right? Now I know all of propane has reacted. So volume of propane reacted would be 75. This will be 5. From here, volume of O2 reacted. This will be 5 times 75, which is 375. This much oxygen had reacted. So volume of oxygen unreacted. This will be total volume minus 375, amount which has reacted. This your 25 centimeter cube. Answer A. Next. So in the actual paper, they would have given you a Maxwell-Boltzmann energy distribution, which is not given here. Now, which one represents a distribution and value of activation energy at lower temperature? Now, activation energy does not depend on temperature. It depends whether you have a catalyst or not. So activation energy cannot shift. So I can skip B and D because in B, like in the actual paper, the activation energy line was somewhere here, right? As activation energy has shifted, that can never be the right answer. So B and D got eliminated. Now at lower temperature, what happens? The peak will shift to the left. Yeah. Initially, the curve should look like this, but as you have decreased temperature, the peak should move to the left and move up. So this is your new peak. Yeah, and the activation energy remains the same. Answer would be option A. Next, the volume of gas produced in a kinetic experiment is plotted. You have to find the average rate for the first 20 seconds. So average rate would be In 20 seconds, it's 40. At 0, it's 0. So it will be final volume at 20 seconds minus volume at 0 divided by the total time taken, which is 20 seconds. This will give you 2 centimeter cube per second. Option A. Now next, following equilibrium was established. 2HI gives you H2 plus I2. Which changes would shift the position of equilibrium furthest to the left? Now, first for pressure. You see, moles of gas are 2 on both sides. Yeah. So even if I increase or decrease pressure, that will have no effect on the position of equilibrium. Okay. So if I'm changing pressure, I'm technically wasting money. But yeah. So the pressure options are kind of irrelevant to us now. We just have to check the temperature one. So if I look at temperature, it's positive, right? So in the forward direction, heat is absorbed. In the reverse direction, heat is released. Yeah. So if I decrease temperature, then the equilibrium will try to increase temperature by releasing heat. So the left means the reverse direction. Yeah. The reverse reaction is only favored when heat is released, and heat will be released when you're decreasing temperature. The temperature would be decreases, which corresponds to B as our correct answer. Next. Which two species can be both Bronsted-Lowry acid and Bronsted-Lowry bases? We need two species which can accept H plus and at the same time donate H plus. In option A, I can directly reject this because PO4 3 minus cannot donate any H plus. Yeah. Next, here, HPO4 2 minus. So this can be the right answer because HPO4 2 minus can donate an H plus and also add an H plus to form H2PO4 minus. And for H2PO4 minus, you can remove an electron to form HPO4. Remove a hydrogen to form HPO4 2 minus. You can add a hydrogen to form H3PO4. So answer would be option B. In part C, obviously, you have this, which cannot donate H plus, and you have this again in option D, which cannot donate H plus, right? Next, the pH is 3. We have to find the H plus ion concentration. The formula for H plus ion is 10 to the power of minus pH. You see 10 to the power of minus 3. So 1.2 times 10 to the power minus 3 would be the answer. Next, we have the reactivity series. Yeah, we have to find which reaction is spontaneous. So if a reaction is spontaneous, a more reactive element will remove a less reactive elements from its ionic state or from its salt, whatever you say. CD2 plus and PB. CD is here, PB is here. PB is less reactive than CD, so PB cannot remove CD from its salt. So this reaction is not spontaneous. Next, Fe2 plus and Sn. Fe is here, Sn is here. Again, Fe is more reactive than Sn. Yeah. If the ion is more reactive, then there will be no reaction. The metal has to be more reactive than the ion so that the metal can, displace the ion from its salt. Rejected. Zn and Cu. This is Zn, this is Cu. Zn is the ion, Cu is the metal. So again, Cu is less reactive than Zn. It cannot replace zinc from its salt. Ni2 plus and cobalt. This is Ni and this is cobalt. Yeah, cobalt is more reactive than the iron, right? So only option D would be spontaneous. Question 27. Which alcohol and conditions would produce the highest yield of methyl propanoic acid? Yeah. Now, if you're converting alcohol to an acid, the condition should be reflux. If you want to convert alcohol to aldehyde, then you have to distill the solution. Distillation is as soon as a drop of aldehyde is formed, you will just convert it to vapor such that the aldehyde does not get converted to carboxylic acid. Yeah. So I can first reject C and D because alcohol to acid requires reflux. This is all known information. Now we have to check the compounds. 2-methyl-propanol. This is 2-methyl-propanol. This cannot be oxidized because it's a tertiary alcohol, right? Tertiary alcohols cannot be oxidized. Secondary can be oxidized to ketone, and only primary alcohols can be oxidized to carboxylic acid. So A is incorrect. Next, this is B. For this one, if you oxidize it, you will get a carboxylic acid, which is methyl propanoic acid. Answer would be option B. 29. Which row correctly shows heterolytic fission? In heterolytic fission, ions are formed. Ions are formed and electrons are shared unequally. So B and D are eliminated because it forms free radical. In A, electrons are shared equally. Of course, cannot be possible. You won't get ions. So answer is option C, where both electrons will go to the Br, which contains the negative charge. Now, this is the last question for this paper. Half reactions are given. We have to construct the balance reaction. Now, to construct a balance reaction, we have to make sure the number of electrons are equal. So I can multiply the first reaction with 2 and the second reaction with 3. That will make the first reaction 12 electrons and the second one 12 electrons again. So twice CH3OH, twice H2O. You see twice CO2 plus 12H plus 12 electrons. Okay. Now for this, you'll have 12H plus 3O2 plus 12 electrons gives you 6H2O. Now, when you add these two reactions together, it's more like mathematical equations. You can cancel 12 electrons from both sides. Okay. You can cancel 12H plus on both sides. H2O and 6H2O, you can make this 4H2O on the right. So finally, you'll have 2CH3OH plus 3O2 gives you twice CO2 and 4H2O, which corresponds to option A. Yeah. And with this, we are done with paper 1A of Chemistry SL, and I'll soon start posting the paper 2 solutions. Thank you so much. See you again soon. Bye bye.